So welcome to lesson 4. Today we'll talk about solving quadratic equations graphically. So in order to do this, we're going to review the two methods we've learned to solve quadratic equations, both factoring as well as the quadratic formula. Then we're going to start looking at quadratic functions, the related quadratic equations, and what the solutions of a quadratic equation means to a corresponding function. I know it sounds confusing, but we'll go through it slowly. So the first thing is the minds-on activity, solving quadratic equations. For the last 2 days, we learned how to solve quadratic equations. So what two methods can we use to solve quadratic equations? When do we use each method? Well, there's two methods. The first one is factoring. And the second one is the quadratic formula. So when do we use each method? Factoring, it's always first method you should try. So whenever you have a question that says solve this quadratic equation, always try factoring first. If it works, great, you can solve it. If it doesn't work, so if equation can't be factored, that's really the only time where you want to use the quadratic formula. So this exercise says solve the following quadratic equations. Again, this should be completely reviewed. So what I want you to do now is pause the video, do these questions, and I'm just going to show you the answers. There is one thing that I want to show you before you delve deeper into this. These equations, so remember the first step always is to simplify both sides, bring everything to one side, and then you can start factoring or putting it into the quadratic formula. But there was something I kept emphasizing. You always want your A value to be positive. Here it's negative, so I do suggest you take everything, move it to the other side before you start part A. So when you move it to the other side, this will become 2x squared plus 3x minus 7 is equal to 0. So again, we moved everything to the other side. All of the negatives became positives. The positive became negative. Now you're ready to solve. So again, pause the video, solve it, make sure you got the right answer. So here is the right answer. I'm just going to quickly take you through it. So again, you should have gotten these answers. This is all reviewed from the previous lessons. So after we bring everything to this side to make the A positive, you should have tried to factor it, because remember, we always start with factoring, but you should have realized that it cannot be factored. Once you realize that, you put it into the quadratic formula. So again, remember your A value is whatever's attached to your x squared, your B value is whatever's attached to your x, and your C value is whatever's attached whatever is not attached to anything. It's the lone constant number. So once you have your A, your B, and your C, all you're doing is you're plugging in these numbers into this formula. Remember, when you're plugging in numbers, they're being put in brackets, and you have to keep the sign. So C is not 7, but -7. So you need to put that whole -7 in lieu of C into the formula. Once you get to this part, remember I said to do this part off to the side. When you do it off to the side, it gives you 65. This is what we're left with. Remember, the plus minus means there's two different answers here, one with the plus and one with the minus. So the first answer is -3 plus root 65 divided by 4, and the second one is -3 minus root 65 divided by 4. On the other hand, for B, we were able to factor it. So remember, with factoring, you always start with greatest common factor. So even if you didn't do greatest common factor, you would have still ended up with the right answer, but I would have taken off marks because you didn't factor properly. So greatest common factor out first, and then we notice that this is a trinomial. We can continue to factor it, set each factor with an x to 0, solve for the x values, and this is your answer. Again, this should be review. If you weren't able to get these answers because you totally don't understand it, you need to go back and watch our previous 2 lessons. If you just made a small mistake, again, you just need to edit your work as you go through. So what do these x values actually mean? So we're solving quadratic equations, which means let's take a look at A. I can take this x value plug it into these x's. And when I do that, the left side 0 will equal the right side, which once I plug this in will eventually also equal 0. Similarly, if I take this x and plug it in, the left and right sides will equal each other. Here, if I take the -4, plug it in, the left and right sides will equal each other. Or if I take the 2 and plug it in, the left and right sides will equal each other. So what do these x values actually represent? Well, these are the specific values of x that make the left side of the equation equal the right side. Sorry, the left side of the equation equal the right side. So again, that's what solving for x's mean. When we're solving for x's, we're essentially trying to find the value that we can plug inside the equation to make that statement true, to make the left side equal the right side. So we know we have these tools to solve quadratic equations. What we're going to move on to is we're going to look at the relationship between quadratic functions and their related quadratic equations. So inquiry activity, we're going to do this together, and then you're hopefully going to see some patterns so that we can make conclusions. So before we form conclusions on the relationship between quadratic functions, remember a quadratic function will be in the form fx is equal to ax squared plus bx plus c if it's in standard form, or we can present it, convert this to vertex and factored form as well. So all of them work as long as there's the x variables on one side and there's the f of x or the y variable on the other side. It's the function. So we're going to look at the relationship between quadratic functions and their related quadratic equations. But before we can do that, we need to know what the difference between a quadratic function and a related quadratic equation is. So the exercise, convert the following quadratic functions into their related quadratic equations. In this case, all the quadratic functions happen to be in standard form, but technically they can be in any form. To convert a quadratic function to a related quadratic equation, all we're going to do is replace the f of x with 0. So here it would be 0 is equal to negative x squared plus 8x. Similarly here, replace the f of x with 0. So 0 is equal to negative x squared, negative 2x plus 3. And so on and so forth. So the other ones are exactly the same. Just replace fx with 0. And here 0 is equal to x squared minus 2x plus 1. So here we have quadratic functions. Here we have related quadratic equations where essentially the y variable has been replaced with a 0. So why is this a function? Again, because it has both the y and the x, and it's a quadratic function because the highest degree on the x is 2, whereas the degree on the y is 1. This is a quadratic equation because there is no y here, there's only x's, but also quadratic because the highest degree on an x is 2. So really, it's the y that seems to be the difference between quadratic functions and the lack of y for a related quadratic equation. So let's look at the relationship between quadratic functions and their related quadratic equations by one, solving the related quadratic equation, looking at the graph of the quadratic function and their x-intercepts, and by noting any pattern that you see. Okay, so this should say noting any patterns that you see. So we have these 4 examples here. I'm going to go through 2 of them. I'm going to let you try the other 2 on your own, and then we're going to form conclusions. So for the first question, we have our quadratic function. Again, how do we know it's a function? So I'm going to keep repeating this. The difference between the function versus the equation. So we know it's a function because we have the f of x or the y as well as the corresponding x, and it's quadratic because the highest exponent is a 2 on the x. So we have the quadratic function. We also have the graph of this particular function. So the first step was to solve the related quadratic equation. So the related quadratic equation to this is, again, where we replace f of x with 0 and we copy down everything else. Now, something to keep in mind, again, we don't really like when the a value is negative here. It's easier if it's positive. So let's move everything to the other side to make the a value positive. So negative x squared on the other side will become positive x squared, and 8x on the other side will become negative 8x, which is equal to 0. It's 0 on this side because everything was brought over to the other side. There's nothing left on this side. Now we have a quadratic equation. So again, this is not a function, but an equation, because we only have our x variables here. So this is a single variable equation. There are other versions of equations, but we're going to focus on single variable equations. So there's only one variable here, and it's quadratic because the highest exponent on the x is a 2. Now to solve, we have two options again, factoring or quadratic formula. Let's factor first. You're always looking for the greatest common factor first. So if I take the greatest common factor out of both of this, it'll be x. So if I say x times what gives me x squared, x, and x times what gives me negative 8x, negative 8 is equal to 0. Now that it's fully factored, I can set each factor to 0. So remember, this is in its own secret bracket. So my solutions are x is equal to 0, and x minus 8 is equal to 0. So x is equal to 8. So here we can write the solutions to our quadratic equation. So x is equal to 0 as well as 8. And now we're going to compare these to the x-intercepts, or the zeros, of the quadratic function. If I go back to my quadratic function, it has two x-intercepts, here and here. So the first one occurs at 0, 0, and the second one occurs at 8, 0. So what pattern do you notice here? Okay, I want you to keep that in your mind. We'll do one more example, and then we'll consolidate what the pattern actually is. So you should start to see some sort of pattern. Let's see if this is true for other examples as well. So here we have a quadratic function again. Again, function, because it has the y and the x. We're going to find the related quadratic equation and solve it. So to find the related quadratic equation, again, replace f of x with 0. So 0 is equal to negative x squared, negative 2x plus 3. Here, again, the a happens to be negative here. So I don't really like the fact that my a is negative here. I'm going to move everything to the other side. So negative x squared becomes x squared, negative 2x becomes positive 2x, and positive 3 becomes negative 3 is equal to 0. I do want to emphasize something at this point. You are able to move these across the equal sign because it's an equation. You wouldn't be able to move it across the function because if I move the negative x squared over, yes, it will be positive x squared, but on this side, I'll have positive x squared plus f of x, which makes no sense. So for the function, keep it as is, fx on one side, everything else on the other side. But for the equation, you can move it over because it's a 0 on the other side. So hopefully that clears that up. So we're left with x squared plus 2x minus 3. Again, there's two ways of solving this. I can factor it, or I can, I can factor it, or I can use the quadratic formula. So always start with factoring. So it's a trinomial here. I saw that there was no greatest common factor. Again, I'm not going to show you the factoring steps. That should be well versed at this point. And you'll be left with this. So each factor can equal 0. X plus 3 is equal to 0, so x equals negative 3. And x minus 1 is equal to 0, so x is equal to 1. So the two solutions I have for my quadratic equation are 1 and negative 3. Again, let's compare this to the x-intercepts, or the zeros, of my quadratic function. So I see the x-intercepts are here and here. So the x-intercepts occur at 1, 0, as well as negative 3, 0. So again, note the pattern that you see. Tell me if you see the same pattern that you saw, or think about if you see the same pattern that you saw in the previous example. And the answer should be yes. I'm going to tell you what this pattern is. So again, we had a quadratic function. When we converted the quadratic function to a related quadratic equation and then solved for it, the solutions of the quadratic equation happen to be the same as the x-intercepts, or the zeros, of the quadratic function. Again, there's a lot of terminology happening here. We started with a function, went to an equation, then solved the equation. We say an equation, the x values are solutions of the quadratic equation. So the solutions were 0 and 8, but these same solutions become, or are, the x-intercepts, or the zeros, of a quadratic function. Again, I'm going to say that one more time so that you can follow along. We had a function. We converted it to an equation. How do we know? Because the function has a y and x. The equation only has the x. Again, we're only dealing with single variable equations here. So we converted a function to an equation. We then solved the equation. The solutions of the equation happen to be the same as the x-intercepts, or the zeros, of the function. Let's keep going with the next two examples. I'm going to show you one more example because there is something I wanted to kind of mention there, and then I will let you try the last one on your own. So let's take a look here. The quadratic function here is 2x squared minus 4x plus 3. So let's write the related quadratic equation. So I'm going to replace f of x with 0. So 0 is equal to 2x squared minus 4x plus 3. Again, we have two options: try factoring it or using the quadratic formula. I'm going to ask you to pause the video right now, try factoring it, and then if you can't use a quadratic formula, come back to see if you get the same answer as me. I want to make sure that you can get the same answer as me. So pause it now and then check your work in about 10 seconds, or as soon as you finish it. Okay, so when you put this, so you should have first of all realized that it can't be factored. Then you should have put it into the quadratic formula, and it should give you something that looks like this. There's something we haven't talked about when it comes to square root. So I want you to try this. Take out a calculator, put square root -8 into your calculator. Okay, so try it on your own, and then I'm sorry about that. I'm going to do it as well and show you what my calculator gives me. So if I take my calculator and put the square root of -8, it gives me MA error, which means math error. So something you need to keep in mind is that you can never have a negative value underneath a square root. If that occurs, that means this particular number does not exist. So again, if you have a negative value underneath the square root, that value doesn't exist, which means the x here, there's no specific solutions for the x as well. So no solutions. Why? Because you can't add 4 to something that doesn't exist and divide it by 4, or subtract something that doesn't exist from 4 and then divide it by 4. So if one part of this expression doesn't exist, then the whole thing doesn't exist. So there are no solutions, no particular solutions to this quadratic equation. So what are its solutions? Well, there are no solutions. In the previous two examples, we saw that the solutions to a related quadratic equation were the same as the x-intercepts of the quadratic function. Well, if there are no solutions to the related quadratic equation, then there should be no x-intercepts of the quadratic function, which is what we see here. Remember, the x-intercepts have to cross the x-axis. There's no value, or there's no part of the parabola that crosses the x-axis here. So the x-intercepts, there are no x-intercepts. So hopefully that's clear. Again, When there's a negative value underneath the square root, that part doesn't exist. That's a math error, which means this whole thing is a math error. There are no solutions for x. And when there are no solutions for the related quadratic equation, there's also no x-intercepts for the quadratic function, which is what we see here. So the next example, you should be able to try on your own. So pause the video now. When you come back, I'm just going to have the answers there, and I'm just going to quickly take them up, and then we'll form our final conclusions. Okay, so I have the last one done for you. So we had the function. We converted it to a related quadratic equation by replacing the f of x with 0. I then factored it, so I got x minus 1 times x minus 1. Remember, if you have something like this, we could change it to x minus 1 squared. When I was solving the equation, there was only one bracket to set to 0, so I set it to 0. It gave me x is equal to 1. So the solutions of the quadratic equation is x is equal to 1. If I take a look at the function's x-intercepts, it's 1, 0. Again, emphasizing that point that the solutions to the related quadratic equation are equivalent to the x-intercepts of the quadratic function. So going back here, there were 2 solutions and 2 x-intercepts. Again, 2 solutions to the equation, 2 x-intercepts to the function. Here, there were no solutions to the related quadratic equation, and therefore no x-intercepts to the function. And here there was one solution, sorry, I should have put it at that, one solution to the quadratic equation, and therefore one corresponding x-intercept for the quadratic function. So what is the final conclusions that we can form? The solutions, also known as roots, so a synonym to solutions is roots. So the solutions of a related quadratic equation are the x-intercepts or zeros of the corresponding quadratic function. Okay, so that's the conclusion that we've kind of seen all throughout these 4 examples. What I do want to emphasize is don't mix these words up. X-intercepts and zeros are words that are used with functions, particularly quadratic functions. They can be used with other functions as well, but solutions and roots we're specifically using with quadratic equations. So if I take a look here, so these are, sorry, here. So this was the solution to the quadratic equation. If I said this is the 0 of the quadratic equation, that makes no sense because zeros and x-intercepts represent functions, whereas solutions and roots represent quadratic equations. So I could have said solutions to quadratic equation, or I could have said roots of quadratic equation. Those both would make sense. Okay, so what I want you to do is I want you to do handout A number 1 as well as page 149, number 3 and 14. Again, I want you to do them, take a picture and send it to me on our Google Classroom. Thank you.